In the frozen silence of space, something unimaginable lurks. It does not shine like ordinary stars. It does not beckon with the familiar glow of suns or galaxies. Instead, it hides in the shadows. An invisible monster forged in the most violent deaths the universe can stage. These are stars that lived fast, died young, and collapsed into corpses so extreme they defy imagination. A teaspoon of their matter weighs more than a mountain. Their magnetic fields are so intense they can tear atoms apart from thousands of miles away. They are called magnetars, objects so rare and violent that even black holes seem almost ordinary. Beside them, if one drifted too close, it would erase every credit card on Earth, fry every electronic circuit, twist our magnetic field into chaos, and bathe our world in radiation in less than a second. Life as we know it could end. Yet these monsters are not just destroyers, they are also teachers. In their fury lies the story of how the universe bends its own rules, and perhaps the clues to mysteries we have yet to solve. Tonight, we venture into the heart of stellar death. We will watch a giant star collapse, feel the crushing density of matter squeezed beyond comprehension, and witness the birth of one of the most terrifying objects in existence. This is not just astronomy, it is a journey into the outer limits of physics itself. Prepare yourself. The story of magnetars begins not with silence, but with a bang. Every star is a balancing act. Nuclear fusion in its core pushes outward, while gravity pulls inward for most of a star's life. These forces remain in harmony. But balance cannot last forever. Our sun, a calm and steady star, will keep this balance for 10 billion years. It burns hydrogen into helium at a leisurely pace. A slow and steady fire that sustains life on Earth. But some stars are impatient. Imagine a star 20 or 30 times more massive than our sun. These giants burn their fuel with reckless speed, racing through the elements in just a few million years. First hydrogen, then helium, then carbon, neon, oxygen. Silicon each stage faster than the last, until finally, the core fills with iron, and here the star meets its end. Iron cannot release energy through fusion. When the core fills with it, the star's engine stalls. Gravity, long held at bay, seizes control. In less than a second, the star collapses. The core, once the size of a planet, shrinks to just 12 miles across. The surface falls inward at tens of thousands of miles per second. The crash is violent beyond comprehension, and when the outer layers rebound, they ignite the brightest explosion in the cosmos, a supernova. In a heartbeat, the star's life ends, and something stranger is born. Sometimes a black hole, sometimes a neutron star, and in the rarest of cases about 1 in 10 a magnetar. Picture the island of Manhattan. Now imagine crushing it down until it fits into a sphere the size of a city block. That is a magnetar, the remnants of a collapsed giant, weighing more than our sun, yet only 12 miles across. To understand its density, imagine a teaspoon of magnetar material on Earth. That spoonful would weigh 1 billion tons, more than every skyscraper, every car, every bridge on the planet combined. Drop it, and it would tear through Earth's crust, mantle, and core, emerging out the other side like a bullet through paper. What makes this possible? Inside a magnetar, atoms themselves collapse. Normally, atoms are mostly empty space, a nucleus surrounded by electrons orbiting at a distance. But in a magnetar, the crushing gravity forces protons and electrons to merge, creating neutrons. The empty space inside atoms vanishes. The star becomes one giant atomic nucleus on its surface. Gravity is 200 billion times stronger than Earth's. If you weigh 150 pounds here, you'd weigh 30 trillion pounds there. Standing on its surface is not just impossible, it is unimaginable. Your body would flatten thinner than a strand of hair in a fraction of a second. Yet density, terrifying as it is not the true horror of a magnetar. The real monster is its magnetic field. Deep within the magnetar lies a crust made of neutron-rich matter, harder than diamond, stronger than steel. But even this shell has limits. Over time, magnetic stresses twist it, strain it, and finally snap it. When the crust breaks, the result is a stark-waking explosion, and so powerful it dwarfs anything we have ever known. A single starquake releases more energy in 1 second than every earthquake on Earth over the last million years combined. The cracking of the crust snaps magnetic field lines like rubber bands stretched to their breaking point. The reconnection of these lines releases bursts of X-rays and gamma rays so intense they can be detected across the galaxy. In March of 1979, satellites orbiting Earth suddenly went blind. They had been overwhelmed by a flood of gamma rays unlike anything ever seen. At first, scientists thought it might be a nuclear test in space. Panic rippled through military command centers, but the truth was far stranger. The radiation came from a magnetar, thousands of light years away, unleashing one of the most violent events the universe had ever revealed. And that was just the beginning. In 2004, another magnetar flared with such power that it disturbed Earth's upper atmosphere from 50,000 light years away. If it had been closer, it could have ended life on our planet. But energy bursts are only part of the story. Magnetars also bend the rules of physics themselves. The space around a magnetar is not normal. Its magnetic field is so intense it changes the very nature of the vacuum itself. Normally, empty space is nothing, but near a magnetar, even nothing is altered. Light traveling through it can split into two parts. Photons can merge, divide, or vanish into virtual particles. This effect, known as vacuum birefringence, was predicted by quantum theory for decades before finally being observed in the glow of a magnetar. Atoms no longer behave as atoms, instead of neat spheres of electrons orbiting a nucleus. Electrons are squeezed into long, needle-like shapes, forced to align with magnetic field lines. Chemistry dissolves into chaos. At 600 meters from the surface, the magnetic field is strong enough to tear light itself apart at even closer ranges. Protons and neutrons, the very building blocks of atomic nuclei, begin to stretch and distort. The strong nuclear force, the most powerful in nature, is challenged by the fury of magnetar fields. Here, in this impossible environment, matter takes forms unknown anywhere else in the universe. These stars are not just cosmic corpses. They are laboratories where the universe itself experiments with new rules, the nearest known. Magnetar is about 9,000 light years away, for now. That distance keeps us safe. But imagine if one were closer. At 1,000 light years, a single outburst could strip away Earth's ozone layer. Without that protective shield, ultraviolet radiation from the sun would bombard the surface. Oceans would sterilize, forests would wither, life would falter. At 500 light years, the radiation from a flare could trigger mass extinction. Countless species would vanish in days. The biosphere itself would collapse. At 100 light years, the skies would blaze with lethal energy. A magnetar burst at that distance would bathe Earth in a dose of radiation equal to detonating every nuclear weapon ever built at once, at 10 light years. Earth's magnetic shield would unravel completely. Solar winds and cosmic rays would strike the surface directly, searing away the atmosphere, boiling the oceans, and leaving Earth a barren husk, and at a single light year. Survival would not be possible. The magnetic field alone would shred atoms, and weaving the matter that makes up life, rocks, oceans, and even the air itself, Earth would dissolve into dust. We are alive today only because magnetars are rare. There may be only 30 in the entire Milky Way, yet even in their rarity, they wield influence far beyond their numbers, for in their fury, they may hold answers to the universe's strangest mysteries. For decades, astronomers have been hunted by a strange phenomenon. Fast radio bursts, millisecond flashes of radio waves arriving from deep space. They appear suddenly, vanish instantly, and release more energy than our sun emits in days. Some repeat, most do not, for years. No one knew what could possibly cause them. In 2020, the mystery cracked. A magnetar in our galaxy erupted, releasing a burst of X-rays and, at the same moment, a powerful radio pulse for the first time. Scientists had caught a magnetar in the act of producing a fast radio burst. It was proof these monsters are engines not only of destruction, but also of strange signals that ripple across the cosmos. But the mystery doesn't end there. Heavy elements such as gold, platinum, and uranium require extreme conditions to form. Supernovae explain some of their creation, but not all. Magnetars, with their titanic bursts of neutrons and unimaginable pressures, may be the factories where much of the universe's gold was made. The jewelry on your hand, the circuits in your phone, the uranium in reactors all may trace their origin to the violent heart of a magnetar flare. Even darker mysteries whisper from their shadows. Some theories suggest magnetars could help us detect dark matter, particles like axions, hypothetical carriers of hidden mass, may reveal themselves when interacting with magnetic fields this strong. If true, magnetars might already be broadcasting the fingerprints of dark matter into space, waiting for us to decode them. In their violence lies not just terror, but knowledge. They may be gateways to understanding why the universe looks the way it does, and what unseen forces shape its destiny. As terrifying as they are, magnetars do not live long. Their magnetic fields, though titanic, decay quickly. Within 10,000 years, a blink on cosmic scales, their fury fades, the bursts cease. The quakes subside. What remains is a quieter neutron star, its rage spent. Yet in those brief millennia, magnetars influence galaxies. Their bursts flash across billions of light years, visible to telescopes on Earth. They scatter heavy elements that seed the birth of planets. They bend space, twist light, and test the very limits of physics. And then, just as suddenly as they arrived, they fade into the background hum of the cosmos, becoming one more dead star among countless billions, rare, short-lived. But unforgettable magnetars are the universe's most violent punctuation marks. Brief explosions of terror in the long sentence of cosmic time. But even in death, they leave behind mysteries and scars. The echoes of their bursts ripple through space. Their elements live on in the planets we walk upon, perhaps even in the gold in our bloodstreams. Magnetars may be killers, but they're also creators. So what are magnetars? They are nature's most terrifying laboratories, places where the rules of matter, energy, and light break down. They are destroyers that could, if fate had placed them closer, and make our world in an instant. And they are creators, forging the elements that make planets, jewelry, technology, and even life itself possible. They are a reminder of the universe's extremes, of how fragile we are. Our world spins quietly in a safe corner of the galaxy only because chance has spared us. Yet somewhere out there, beyond the stars we see, these monsters exist, hiding, waiting, occasionally erupting in flashes so bright they outshine galaxies. But maybe they are more than threats. Maybe they are guides. Perhaps within their impossible fields and unimaginable bursts lies the answer to questions humanity has chased for centuries. What is dark matter? How did the universe evolve? What forces still wait to be discovered? The next time a satellite catches a sudden flood of radiation, or a telescope picks up a flash from deep space, it may be a magnetar reminding us that the cosmos is not silent. It roars, it rages, and in its rarest moments, it creates monsters. The universe is filled with beauty, but hidden within that beauty are terrors beyond imagination. Magnetars are proof of both cosmic killers and cosmic creators, born in fire, burning with fury, and gone in a flash, and they are real. If you want to continue exploring the universe's strangest and most dangerous secrets, join us again, because out there, in the darkness, the monsters are waiting.